Hi everyone. So we are on day 4 of Unit 3, and we're going to be talking about derivatives with inverse trig functions. So the first thing we're going to kind of talk about before we get going into all of the calculus part is we're going to discuss the pre-calculus. So let's see if we kind of remember the graphs of all of the trigs. So we have our sine function. If we remember, our zeros are at all the pi's, basically. And then the maxes and mins are in between those two. So you keep adding on like the negative pi over 2 to pi over 2, 3 pi over 2, 5 pi over 2, all of those. Okay, so when I wanted to find the inverse function, in order for an inverse to exist, we have to be 1 to 1. So every input and output can only match each other once. And so we learned when we did this, it had to pass a horizontal line test for an inverse to exist. And so if the graph passes and touches a horizontal line more than once, then the inverse will not exist. So here we have to go kind of limit the domain and range. So our domain's going to go from negative pi over 2, pi over 2, and our range is going to go from, that's negative 1 up to 1 for this sine function to have an inverse. So what we do is we flip-flop when we have inverses. So over here, my domain will be what the range was, from negative 1 to 1. And here I can see I'm going from negative 1 to 1. And then my range is what the domain was, so from negative pi over 2 to pi over 2. So we did a little bit with inverses, on the last day, but here now we can see the graph of the inverse of sine. So we can do that similarly with all of the different trig functions. So here, where we're going to limit our domain, okay, it's just right from 0 to pi, and then same thing, you're going to flip-flop your domain and range. For tangent, you're just going to use this guy, and then there's your arctan. So, and those, you can do it for the rest of all of the trig, all 6 functions, but those are the main ones that we need to know. So I might look over those in more detail and pause me if you need to. So this is just some of the notation, so we make sure that if I see this to the negative 1, this is talking about the inverse. This is the exact same thing as saying the arcsine of x. So it means exactly the same thing. Okay, so getting into the calculus a little bit more, we have to have these derivatives. So if I wanted the derivative of the inverse of sine, so we kind of think about it with the chain rule here. So if we have this inside going on inside sine, then we're going to do the square root of 1 minus that inside squared, and then times the derivative of that inside. That's where the chain rule comes in. So this would be the derivative of arcsine. So the derivative of arc cosine, if you look, is exactly the same, except for derivative of c's, we've already learned, go negative. Otherwise, it's exactly the same. Tangent doesn't have any square roots, and instead of a minus in the denominator, it has a plus, and then it's very, very similar. So no square root, a plus instead. And cotangent's going to be with a negative, but other than that, it's just like the tangent. And then arcsecant here is very different. It's got these guys flipped from what we saw in the very first one from arcsine. And it has the absolute value of that inside down here in the denominator, as well as still taking times the derivative of that inside. And then the arc cosecant is everything's the same except for the negative, like we're seeing with all these negatives. So really you have 3 formulas that you have to get memorized, and remember that any of the c's that are kind of corresponding go negative. Okay, so let's do an example here. So I want to find dy dx. Well, the derivative of 7 becomes 0, so I don't need to write that. And then I have a minus 2, so that negative 2, woohoo, goes along for the right. Times, now I'm going to have the square root of 1 minus that inside of the arc sign quantity squared, and then times the derivative of that guy. And then it's up to you how much you want to go and simplify it. Maybe you want to bring that 2 up there with it. So negative 6x squared plus 6 over radical, and I wouldn't square this out, I would just leave it. And then maybe flip-flop so you don't have your first term being a negative, or maybe you factored out a negative 6. Sure. Lots of ways to simplify and try to match on a multiple choice, but if it was a free response, then this would be great. Okay, next one, we're going to find the derivative of y with respect to x. 7, along for the ride. And then the tan is 1 plus, there's no radical, instead it's 1 plus this guy right here squared, the inside of it, and then times the derivative of that. And then I'm just going to put these two together. 784. And heck, might as well do that squared out. Power to a power multiply. Okay. Okay, next one. This right here is just saying take the derivative of this inside with respect to x. We can see we're taking it with respect to x. So that's all this is telling me to do. It's just saying, hey, go derive, just without saying the words. Okay, so I see that it's a c. So here, this derivative is going to be negative. It's exactly like what we're going to see with the secant, except for the negative. And if you remember the secant, hold on, let's go to show you so you remember. So it's just like the secant, okay? So except for it has the negative. So that's the weird one that has the absolute value of that inside. And then the radical, and now it's flip-flopped, so it's going to be this inside part squared minus the 1, and then times the derivative of the inside. That's just an easy e, which would be e to the x. Well, having an absolute value around e to the x looks like this. It actually has that horizontal asymptote, so it's always positive. So in this case, we don't even need that. So that's the same as just e to the x. And then those can cancel. And there you go. Okay. Says, hey, if f of x is arctan, then it wants me to find this limit. So I'm bringing back some old stuff, back from Unit 2. So what is this asking me to find? And that's what we have to remember. It's asking us to find what? Well, this is a formal limit definition of the derivative. So it's asking us to find f prime of plugging in radical 3. So if f of x is the arctan of x, then I need to take the derivative of that and then go plug in radical 3. So the derivative of arctan is 1 plus that inside squared times the derivative of the inside, which is 1. And now I can plug in my radical 3. So the square root and the square will cancel here to 3. And I get 1/4. All right, so you guys try this one and see if you can get an answer of 3 radical 2 over 4. If not, then please ask me in class, and I want you to see how you do. All right.